All right, today we're going to take a look at section 6.1, composition of functions. And remember that this is the chapter 6 way at the end of your book, not the chapter 6 that comes after chapter 5. That chapter 6 we cover in Math 1015, not Math 1215. Composition of functions. Anybody know what composition of functions means? All right, here's what composition of functions means. You're going to start with an input. And you're going to take that and you're going to put it into a function. So a function's like a little machine. See, he's got little pulleys and gears and things. And what happens when you take something and you put it into a function? What do you get? Well, you take your input, you put it into a function, and what do you get? What's the opposite of input? Output. You get an output. You get an answer. So this first function, this one might be called f of x. What you're going to do with that output is you're going to take that and you're going to plug it into another function. So this one would be called g of x. So you're going to take an input. You're going to take basically a number. You're going to plug it into a function. When you plug a number into a function, that gives you an answer. That gives you an output. You're going to take that answer and you're going to plug it into another function, and that'll give you your final output. So basically, you're going to take a number, plug it into a function, get an answer. Take that answer, plug it into another function, and you'll get a second answer, and that'll be your final answer. Now, this happens all the time. And it happens so fast that you don't even think about it. For example, let's say you go down to Wegmans and you go down to the bulk candy area and you get yourself a big bag of gummy bears. I like gummy bears, so we'll get a big bag of gummy bears. What happens when you take that big bag of gummy bears up to the register? What do? They weigh it. Okay, so our input for gummy bears, our input is the weight. They weigh the bag of gummy bears. Then what happens?
The weight goes into a function and saying how much it will be.
The weight goes into a function. And the function is, we'll call it the cost function. So basically, if the gummy bears cost $2 a pound, they take your weight and they multiply it by $2. And that gives you the cost. So there's our input. Our input is weight. We put it into the cost function and we get an output of cost. But that's not the end of it. Then what happens?
We live in the great state of tax.
And then they take that cost and they put it into another function. And this function is called tax. And so then you get your final cost. And that all happens so very, very quickly and so very naturally that you don't even think about it. You've never in your life probably thought of that as being a composition of functions. But that's really what it is. They take the weight. Let's say our weight is 2 pounds. And then they take the cost. To get the cost, they take the 2 pounds and they multiply it by, let's say it's $2 per pound, which would mean your cost is $4. And then they take this answer, $4, and they add the tax. What's the tax? How much tax do you pay, do you know? You pay 8% tax, I believe. So they take this answer, they take this $4, and they multiply it by 1.08. Why 1.08? If the tax rate is 8%. Well, what happens when I take the $4 and I multiply it by 1? That's still the $4. And then what happens when I take the $4 and I multiply it by the 0.08? That gives you that adds the tax on. Right. So this would be, I think, $4.32. And so there's an example of function composition. We start with the weight, we figure out the cost. From the cost, we add the tax, and that gives us the total cost.
That's not really that bad for gummy bears, though. I'd pay that.
You pay that for 2 pounds of gummy bears? I have no idea how much gummy bears cost.
I feel like it's got to be more than that for 2 pounds.
Probably. But I don't know.
I'd pay that for some gummy bears.
I don't pay attention. I just buy a big bag
we
and
just
throw it on the
ordered
thing.
some
And
gummy bears.
whatever, it's gummy bears. I'll eat it. All right, so here's how this is going to look in our class. We're going to have 2 functions. We're going to have f of x is, somebody give me a nice linear function. Anybody have their favorite linear function?
2x plus 6.
2x plus 6, that's a linear function. And g of x, I want g of x to be a nice quadratic function. Anybody got a favorite quadratic function? I've got one, I guess. How about x squared minus 9? Why is the first one linear and the second one's quadratic? Because of the exponents, that's correct. The first one is linear because the only exponent on the x is a 1. The second one's quadratic because it has an x squared. All right, so you're going to be asked to find things like f composed with g at 4. So the symbol might be written that way. It might also be written this way. We have 2 symbols for the same thing. F composed with G at 4. In either case, here's what the symbol means to do. It means to start with the number 4. 4 is your input. What are you going to do with 4? Other way around. This is kind of weird. This actually goes right to left. You're going to start with the number 4, and you're going to plug it into G first. And it makes more sense when you have it written this way because it's inside the parentheses. So I'm going to take the number 4, I'm going to plug it into G, and that's going to give me an answer. And then what am I going to do with that answer? Plug it into F. Okay, so what do I get when I take the number 4 and I plug it into the G function? 7. So this is now going to be F at 7. Because G at 4 was the number 7. And then I take 7 and I plug it into the F function. 14 plus 6 is 20. How about if I switch the order? What if I put G of F at 4? Which could be written as G O F at 4. What would that mean to do? I start with the number 4, and where do I plug it in? Now I plug it into the F first. So I take the number 4, plug it into F. I get 8 plus 6. 8 plus 6 is 14. I need to take that number 14 and plug it into the G function. Well, that's going to be 14 squared minus 9. What's 14 squared? 196. 196 minus 9. 187. Notice you do not get the same answers. One of them was 20, one of them was 187. When doing composition, order makes a big difference. When you do FOG, you'll get one answer. When you do GOF, quite often you will get a different answer. Very rarely will you get the same answer. It can happen, but very rarely. Questions on that? What if I asked you to do FOF at -2? What would that symbol mean to do? Take -2 and plug it into F, and then whatever answer you get, plug it into F again. That's correct. So this would be, I take -2 and plug it in there. I'm going to have -4 plus 6, that's 2. So I plug negative 2 into one of the f's, so I got the answer 2. Then I take 2 and I plug it in the f again, and I get 4 plus 6, that's 10. How about GOG at negative 2? Same thing, almost. It means take negative 2, plug it into G. That gives you an answer. Take that answer, plug it into G again. So let's see, I plug in negative 2, I get 4 minus 9. 4 minus 9 is negative 5. So then I'm going to take negative 5 and plug it into G again. When I plug negative 5 in, I get 25 minus 9. That sounds like 16. Questions on that? All right. Now, what if I wrote that symbol, FOG at X, and I didn't put a number there, I just left it as the letter X. What does that symbol mean? That's exactly what it means. It means you start with one equation and you plug it in for X into the other equation. Which equation do I start with? Do I start with the F or do I start with the G? G, yeah, these go right to left. So this means do G first. So I go up to my G function. Here's my G function. What this symbol means is take the G function and plug it in for the X in the F function. So what are you going to do when you get that? What are you going to get when you do that? I mean, you take the G, X squared minus 9, and plug it in there. What are you going to get? 2 times x squared minus 9 plus 6. I take the x squared minus 9 that's here, and I plug it in. There's only one x, so I plug it into that x right there. And I would probably go ahead and simplify. That's 2x squared minus 18 plus 6, 2x squared minus 12. Conversely, I might do GOF of x. And that means to go the other way. That means start with the f function. So I'm starting here, and I'm going to take that function and plug it in for the x over there. Which means I'm going to have 2x plus 6, whole thing squared, minus 9. Now, truthfully, I really don't care if you simplify or not. But my guess is if you go to do your homework on my lab, my guess is that they're not going to accept that answer. They're going to force you to simplify it. So I guess I'll go ahead and simplify it. What do I get when I take 2x plus 6 and I square it? Four x squared plus 36. That's probably the single most common mistake made in all algebra classes. What does this symbol mean? 2x plus 6 squared. It means to take 2x plus 6 and multiply by 2x plus 6. That's what squaring means. Squaring means multiply by itself. You get 4x squared, and then what you forgot is the outside and the inside terms. On the outside, you have a 12x. On the inside, you have another 12x. 12x and 12x makes 24x. And then 6 times 6 is 36. And it's very, very, very common that people will tell me that this is 4x squared plus 36. You got to remember to do FOIL. You got to remember there's those middle terms. They don't cancel out here. All right, so final answer would be 4x squared plus 24x. And then I'm going to have this 36, and I got to subtract 9. 36 minus 9 is 27. So final answer should be 4x squared plus 24x minus or plus 27. Questions on that? All right, the next set of problems you're going to have are going to look like this. You're going to have f of x is x over x plus 3, and g of x is maybe 2 over x. It has some functions with some fractions in them. And the directions are going to be find f composed with g and g composed with f and their domains. All right, domain. We haven't used that word in quite a while. What does domain mean again? All of the x values that you can use. All right, so let's just start with f of x and g of x. F of x is x over x plus 3. What is its domain? What numbers can you plug in for x? Or more importantly, I might ask, what numbers can you not plug in for x? Which one? I can plug 0 in for x on this one, because if I plug 0 in for x, I get 0 on top and 3 on bottom. 0 over 3 is 0, so that's okay. I can plug in 0 on this one. 0 on top is okay. What's not okay? 0 on the bottom. So what number would you plug in that would give you 0 on bottom? Negative 3. So the domain is x is not the number negative 3. I cannot plug in the number negative 3. If I plug in the number negative 3, I get 0 down on bottom. I can plug in any other number that I like, however. And how about for g of x? G of x is 2 over x. Domain is x can't be 0, because that would give me 0 on bottom. Okay, so that's what we have to worry about with those fractions. We have to make sure we don't divide by 0. Okay, so now let's figure out FOG at x. What does that symbol mean to do? Start with which function? Start with g, and what are you going to do with g? Plug it in. So I'm going to take this g function, and I'm going to plug it in. And then I've got to plug it in 2 spots because there are 2 x's. So I'm going to have 2 over x over 2 over x plus 3. And that's okay. But again, I'm pretty sure my lab would not accept that as a correct answer. This is what's called a complex fraction. What we mean by a complex fraction is when we have a fraction bar like this, and then we have either more fractions on top or on bottom. In this case, we have both. We have fractions on top and on bottom. What we want to do is we want to get rid of those complex fractions. And the way we typically get rid of the complex fractions is we look at all the denominators, and we find a common denominator. Well, this fraction's got an x on bottom, this fraction's got an x on bottom, so my common denominator is x. I'm going to take this fraction, and I'm going to multiply everything on top by x, and I'm going to multiply everything on bottom by x. So what do I get? What's 2 over x times x? Well, I have an x on top, and I have an x on bottom. What happens when you have an x on top and an x on bottom? X divided by x is 1. They go away. So that's 2 divided by. Same thing happens here. I have 2 over x. I multiply by that x. The x's divide out. Plus, this one I have 3 times x. I'll just write that as 3x. Okay, so there's my function. There's f composed with g of x. Now, what's its domain? What numbers can I not plug in? Not anything negative. For example, I could plug in -1. If I plug in -1, I would have 2 on top, and then I'd have 2 minus 3 on bottom. I'd have 2 on top, -1 on bottom. 2 divided by -1 is -2. That's okay. So I can plug in a -1. I can't plug in 0. How come I can't plug in 0? Yes and no. What I mean is, if I plug 0 into this function, I'm going to get 2 on top. If I plug 0 in, what am I going to get on bottom? 2. So that's 2 over 2, which is 1, doesn't it? However, x still can't be 0. And the reason x can't be 0 is, remember what the symbol means. FOG would mean I take 0 and I plug it into the g function first. Can I take 0 and plug it into the g function? No, I can't. So it doesn't look like 0 is a problem when you simplify, but 0 really is a problem. I can't plug 0 in because I can't take 0 and plug it into the original g function. So whatever the domain of g was from the beginning, that's still going to come down with your composition. But there's another problem. What number would give me 0 down on bottom of this fraction that I got when I simplified? Well, what happens if I take 2 plus 3x and I set it equal to 0? How would you solve that equation? Subtract 2 and then divide by 3. So my domain would be, x can't be 0 because I can't plug 0 into the original g function, and x can't be -2/3 because if I plug in -2/3 I get 0 on my final answer. That's not acceptable. All right, and then let's try going the other way. F of x, I've got to copy these down again because I ran out of room. F of x is x over x plus 3. And g of x was 2 over x. This time I want to find GOF of x. And then when I get done, I want to find its domain. And what I tend to do is I tend to start with, right away, x cannot be the number -3. I tend to start writing my domain down first. How come x cannot be the number -3? Because if I try to take -3 and plug it in here, I got to plug it into f, it makes the denominator 0. So I get x can't be -3 because of that part. All right, so what I'm going to do now is I'm going to take this function and I'm going to plug it in right there. That gives me 2 over x plus 3. Once again, I end up with what's called a complex fraction, a fraction divided by a fraction. This one I think is easier to simplify though. How do you take a number like 2 and divide it by a fraction? How do you always divide by a fraction? You flip and multiply by the reciprocal. So this is going to be 2 times x plus 3 over x. Think of the 2 as being 2 over 1. I would write that as 2x plus 6 over x. Are there any other issues that I need to add concerning my domain? Any other numbers I need to throw away? 0. Why do I need to throw away 0? X can't be 0. You would get 0 on bottom. Questions on that? All right, the last thing that shows up in this section. I'm going to give you h of x is some function, let's call it 1 minus 3x to the fifth. And the directions are going to be find f of x and g of x so that f composed with g gives you h. So it's kind of like playing Jeopardy. I'm giving you the answer. Here's the answer. The answer is 1 minus 3x all to the fifth. I want you to tell me the two questions. What two functions did those come from? And I'll give you a hint. There are an infinite number of correct answers. So you should be able to come up with one. All right, so let's see. F of x is, g of x is. Can anybody give me an answer? And although there are an infinite number of correct answers, one of them is much more important than all the others. All right, here's a big hint. This symbol, FOG of x, can also be written like this. So notice that g is inside the parentheses. So what do you think g should be? The thing inside the parentheses, 1 minus 3x. So g should be the thing inside the parentheses, 1 minus 3x. And then what should f be? What do you do to the 1 minus 3x? You raise it to the fifth power, so f of x should be x to the fifth. And that's a correct answer. If I take this 1 minus 3x and I plug it in there, I would get 1 minus 3x to the fifth. And that answer is the answer that's more important than all the other answers. Why is that one more important? I can't tell you that until you take calculus. It has something to do with the chain rule for derivatives, whatever that means. But that's the important one. But like I said, there are an infinite number of correct answers. Can anybody give me another correct answer?
1 minus x is 3x.
Another correct answer would be 1 minus x to the fifth for f, and then g could be 3x. That's correct. Because I would take this 3x, I would plug it in for that x right there, and I would have 1 minus 3x to the fifth. That's correct. So you can kind of start to see, why is the first answer more important than the second answer? Well, because this one, in a sense, could be broken down more. This one you could call the inside 1 minus x, and this one you could call the outside x to the fifth. So it's kind of like a prime number sort of deal, except they're kind of more like prime functions. There's really no easy way to make this one more of a composition or make that one more of a composition, but this one you could. Can anybody give me a third correct answer? As long as I said there are an infinite number of them. Well, there's the really stupid answers. And what I mean by the really stupid answers is g of x is going to be 1 minus 3x all to the fifth. If g of x is 1 minus 3x all to the fifth, then what would f of x be?
X.
Just x. So I would take this 1 minus 3x to the fifth, I would plug it into that x, I would get 1 minus 3x to the fifth. Why is that the stupid answer? Doesn't do anything, does it? I mean, that's the same function that we started with. And I could switch them around. I could have f of x be 1 minus 3x to the fifth, and g of x could just be x. That's another stupid answer, but it is correct. But here's how you get an infinite number of correct answers. Another answer could be g of x is 1 minus 3x squared, maybe. F of x would have to be what? X to a power. X to which power?
Third.
Not third. Because if I were to take this and plug it in, if this were x cubed, I would have 1 minus 3x squared cubed. What happens when you have a power followed by another power? You multiply them. So that would give me a sixth power. So you're close. Right idea, but cubed isn't the right number. It has to be 5 halves. So if I had a 2 here and a 5 halves there, I would multiply those exponents. What's 2 times 5 halves? 5. So I could do that with any number. I could put a 2 here. I could put a 3 here, and then put a 5/3 there. I could put a 4 there and put a 5/4 there, so on and so forth. That's how you get an infinite number of correct answers. But like I said, the first one we came up with, that's the important one. And the way it's generally going to work, whatever's inside the parentheses, that's going to be your g of x. Whatever's outside the parentheses, that's going to be your f of x. So those should be pretty simple. Questions on that?